Tom Morley from POS 365 with the second tutorial on coding for the Shadertoy node in Natron. So we left off, I think, at step 4 of the GLSL 2D tutorial, which was nothing more than another background color, right? So I think at this point we need to maybe back up a little bit and talk about a few things. So first thing I want to talk about, I guess, is up till now we've just been basically, let's go ahead and copy the tutorial for section 3 and right click and copy that. Now I'm going to bring up Natron, grab the Shadertoy. So we've been talking about how to cut and paste this code into the Shadertoy node, which is all well and good for us to kind of get our feet wet and understand what's going on with the Shadertoy. So I'm going to expand this image shader section. I'll throw up my key monitor just in case. We're going to kill everything in this box. Then we're going to press Ctrl V to paste in the tutorial 3 code, and if I click reset and auto parameters, it should be blue, which it is. And that's all well and good, but this was just to, I guess, get you familiar with some of the basic code, pulling it from the Shadertoy website over onto the Natron Shadertoy node. But if we want some persistence, that is, we want a file that we can load in every now and then, we're going to have to save that file somewhere, right? So we'll need some type of text editor, and I wanted to try and find one that we could run across all platforms, and I really couldn't find one. I mean, if somebody's got some good ideas for one that works for Linux, Windows, and Mac, go ahead and leave a description down below so that I can check it out and maybe use that. But for now, I know that Notepad++ is on the Windows side, and on the Linux side they have something called NoteQQ, which works pretty much the same way. It's a text editor for Linux that works pretty much like Notepad++. So hopefully I've got a few people that are watching these tutorials that can use either Notepad QQ or Notepad++. You can really use any text editor, but you'll want one that incorporates language so that it will basically color your code so that it's easier to read, right? And you'll see what I mean in a second. So we've been cutting and pasting the code over here in the Natron window, source window, right? So rather than do that, let's go ahead and paste the code in the Notepad QQ text editor. And you'll see when I paste it in here, nothing special, it's all white and it looks just like it does over here. But if you click on language, and it works the same way in multiple editors, we're just going to change this from the language from plain text to C++, and when we do that, you'll see that it basically colorizes the code and makes it a little bit easier to read, right? We see that all of our comments are white and the main function is in red and some of our variables are in green, so it and our float values are blue. It just makes it easier to see what's going on. So we pasted that in the text editor here, and let's go ahead and save this file. I'm going to do a file save as. I've already created a directory for this project, but I'll go through it here. I'm going to go from my home, and I've got a projects folder for Natron, and I've got a coding folder, and I have a Shadertoy folder. There's a specific extension you're supposed to use for the shader code itself. It's just .glsl. So let's just call this tutorial 03, because that's what it is, right? .glsl. I'm going to click save so that it saves it there. And for some reason in this text editor, I lose the fact that it's C++ language. But I'm just going to put that back on. And then all I have to do is, when I change things, hit save, and for some reason after that, it holds the language. So if we come over here now that we've saved this file, we come over here and we can delete all this, right? And if I click compile, of course, it's going to error out. So it means nothing's there. But now I can load that GLSL text file by using this area right here. I'm going to click on the folder. I'm going to go to where that is, which is in my projects, Natron coding, Shadertoy, and there is I spelled it wrong. Oh, no big deal. Tutorial 03 GLSL, right? So I'm just going to click on it. I'll fix the name later. And it loads it up in here. So I'm going to then click the reset parameters and click auto parameters, which auto compiles it, and now it's blue. Okay, same thing as just pasting it into the source window, except for now I have a text file that I can use, right? So let's fix this. Spell it right. And then load up the right one. Tutorial 03, reset auto. So now I've got a persistent text file that I can modify as we go along. So at this point, I wanted to basically have a GUI tool in this Shadertoy to allow me to change the color of this background, right? I could do that by opening up my source file here and changing the colors here, right? Because we got the red channel, the red channel green, and the blue channel, and we can just come in here and I guess hard code it, right? But it'd be nice if I had some kind of GUI over here that I could just click on and change the background color. So let's look at the documentation of the Shadertoy node. Okay, I have it here, but let me show you how to get there. So on Google, you can type in Natron Shadertoy, and you'll find some documentation for the Shadertoy node. Just click on that and it'll bring up the documentation for the Shadertoy node. So you'll see some interesting things here as you're reading the description. Shadertoy node only uses WebGL 1.0, and there's some restrictions as far as it doesn't support multipass shaders or sound. So those we're restricted in kind of what we can implement with the Shadertoy, but there's still a lot of things we can do with it. So it implements WebGL 1.0, no multipass, no sound. And if we come here, we see that image shaders implement a main image. Yep, we've already talked about that in the previous video, right? There's a main image function, and that gets called over and over again, and we give it a frag color, and that's what the color is that we output from the main image. We already know that. But so I'm looking down through here, and is there any way for me to put a GUI on the Natron preference section? So I got looking and down a little bit further, and I guess I had to be aware that there's some inputs that we get with the Shadertoy node for free, and looks like I can find out what current frame it is, or time in seconds, or some other things. So there's some inputs that the Shadertoy accepts. I guess I don't really need to know what they are at this point. I just need to be aware that the Shadertoy has inputs and it also has outputs. We know it has an output, right? As we talked about the frag color. That's the background color that we've been creating. So we know that it has that output. So if you read a little bit in here, and it gets a little bit confusing, but right here in this section here, the shader may define additional uniforms. So I can create a uniform variable. Okay, that's good to know. But this is the cool part. These uniforms can be made available as open effects parameters using the settings in the extra parameters group. So that just means blah 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 to me, I guess. But if you keep on reading, you get the syntax for how to make this uniform show up in your GUI. So there it is right there. So let's say I wanted to create something that I could use to change the background color of the tutorial 3 that we created, right? We know that that's going to be a vector 3, right? And we can just call it background color. So we're going to use this syntax to kind of formulate that GUI interface for the Natron Shadertoy node. So let's go up there and let's bring this text up. Okay, so we see that that's the format that we're looking for, and we know that we've got a variable here called color that's defining the background color. So right after the text up here, so we have to do this in a global fashion. At least I think that's called global fashion. Again, I'm a beginner, I'm kind of stumbling through it. But we're going to use this format here to create something to modify the color. So we're going to type in uniform here. And it's going to be a vector 3, right? We need 3 float variables to represent green, red, green, blue. Vector 3. And we're going to call it the same thing as the variable down here, which is just going to be color. It's already defined for us down here. So uniform vector color, and we need that to equal something. So we want it to equal a vector 3. And let's just set a default value of all zeros so that it's black. So we can say 0.0, comma, 0.0, comma, 0.0, right? And what's next? We need our semicolon. Now we need to type in this as well. So we need a // which is typically a comment right up here. But we use it in this syntax to dictate what the GUI name is going to be. So we're going to put here background color. So whatever you put right here is going to be the name before your GUI inputs. So we're going to say background color. And if we want it to have a pop-up help section, I guess, then we need to put that in parentheses. So in parentheses, we're just going to say sets the background color. Okay, and we need a colon to close that out. So we need to keep it how you see here. And although they don't have the colon on the end, but I'm pretty sure I need that. I guess we'll find out, right? That's what this is all about, stumbling through this. So I've created a uniform vector 3 called color, and I'm assigned it all zeros, which means that it's going to be black. So this is what's going to interact, and you see it lights up a whole bunch of the variables, or at least the same name, color, in this text editor. So that's pretty cool. It highlights some stuff for us. So we created that color variable, and it can be used down here in the main image. So because I defined the color up here as a uniform, I no longer want to define it down here, right? So I'm just going to comment that line out, because we no longer want to assign it here. We're going to assign it using our GUI value, which by default is just going to be all zeros or a black background, right? After the // then that's what the name of our GUI is going to be in the Shadertoy node. And this, I think, should be like a help pop-up. Don't really know because I haven't done that section yet. We're going to see what happens when we run it. So we defined it as black here, and when the main image function executes, then it's going to come down in here and it's going to say that the vector4 pixel variable is going to equal vector4 and color, the color variable assignments of 0, 0, 0 when we first run this, and then the alpha. So if everything works right, I'm going to click save. If everything works right and I bring up Natron, it's right there, and I click the reload and I look at this text, the uniform should be in here, and it is. There's the uniform, and I click reset and auto parameters. Yep, look at that, it went black. But not only did it go, did the background go black, but look up here. We've got a new GUI interface up here called background color, and that background color is set to what we defined in the code, right? 0 to 0, 0, and created a black background. But the cool thing about that is now we've got a tool inside the Shadertoy node to basically change the color of the background to anything we want it to be, right? Well, there. That's pretty darn cool. And you know, you can use this now that you've coded this. You can use this and animate this just like you would any other thing in Natron, right? So go to the first frame, right click on this, set all dimensions for your keyframes, and then maybe from frame 1 to frame 50 I want it to change from yellow to let's say red, and click OK. So now I can go back to the first frame, click play, and check this out. It just goes from yellow to red. So it took me a little while to figure out how to get this GUI interface to pop up. So I kind of wanted to go over that. And here's the interesting thing. Everything has to be in place as far as when you create your uniform and you call it color, you actually have to use that color variable in your code somewhere, because if you don't and you click the reset params and auto parameters, the uniform that you created is not going to show up here. It's got to understand that you've created a uniform and that you're using it in the code. So what do I mean by that? Well, let's just check that out. So let's say, for instance, let's go back to the text, and I created something here called the color. Okay, let's just call it the color. And let's unhighlight this so that we're assigning the color variable in here so we don't get an error when we compile it. But I've created a uniform up here, right, called the color. I've got all the syntax is fine. There's nothing wrong with this whatsoever, right? So I would expect this GUI interface to pop up in Natron Shadertoy node, but watch what happens. We'll save that, go back to Natron, and we will reload it, make sure that we have the change variable name, and we do. There's the color. And if I click reset parameters and auto parameters, you'll see there's no GUI interface up here. And that's because the Shadertoy node is smart enough to know that I created a uniform, but I'm not using it. So it's not going to give you the GUI up here, I assume, because you're not using it in your code. So that, to me, I guess that tripped me up a little bit in the beginning. So you have to use your uniforms in your code for it to show up when you click auto parameters. So that's a pretty cool tip to remember. So we could fix that, right, just by going down here, and we can keep it the color as long as we kill this, and wherever we use color in our code, we use the color, right? So we're using the variable uniform variable you created up there down in our code somewhere. So now if I save that and reload it, it should work fine. Reset and auto, and yep, there our GUI popped up. And if I hover over this, I think it might give me my text. Yep, see it. So now if I hover over there, any of these parameter values, it tells me that this float variable is going to set the background color. So that's pretty cool. I haven't used that yet, so that's kind of neat for me to see as well. So That's how you would create uniforms in your code and use them to create a GUI interface in the Shadertoy node. That's going to become important later on, right? Good stuff. So moving on, we were at tutorial number 5, I believe. So let's take a look at that and see what it does. Let's go up here and hit 5. Compile it. Oh, okay. Well, now we've got at least more than one color, so we're stepping up. Let's check number 5 here. Let's grab the whole thing. Let's copy it and let's paste it into our text editor. Let's create a new file and just paste it in here. And the language is going to be C++. This is GLSL code. So I went to G to see if there was any, native language for GLSL. And there's not, but I guess it's close enough to C++ so that the syntax is the same. So I just use C++. Let's save this as tutorial 5. And there we go. So save this as tutorial 5, and let's take a look at what's going on here. So coordinate system, frag chord. Okay, so this is new. We're looking at a new variable called frag chord. I'm going to highlight that, and you'll see that it shows a couple of different things down here. So frag coordinate is an input variable. So it's an input variable. It tells us at which pixel we are on the screen. Coordinate center is the left bottom corner, and the coordinate values increase towards the right and upwards. So basically, every time that we go into this main function, frag chord is going to represent 1 pixel on the screen. So it's going to iterate over this main function, many times, but every time it goes in it, it's only referencing 1 pixel. And that 1 pixel is represented by the frag chord variable. So that's pretty cool. The main function is run for every pixel. Yep. GPUs have many cores, so the function calls for different pixels can be calculated in parallel at the same time, which just means it's going to happen super fast. This allows for higher speeds. Okay, you guys can read that. So we highlighted frag chord, and that's part of the main image function, right? I guess we have this input and we also have an output. The output was the frag color, which we already knew about, but every time it comes into this function, it's going to be addressing 1 specific pixel, and that pixel is going to be represented by the frag chord variable. So it looks like we're choosing or creating 2 different colors here, right? And then we're creating something, a vector 3 here, variable called pixel. If the x coordinates is greater than 100, then plot color 1, else plot color 2. Okay, so we're creating a variable here that's going to be the width of a strip, and we can see that here in the fact that this pink looks like it's about 100 pixels wide. Okay, so we're defining how wide that color 1 is going to be. I believe that's color 1 by defining the strip width. So then we've got an if-else statement in here that just basically says that if the pixel we're looking at in the x direction is greater than the width of the strip or greater than 100 pixels, then we're going to assign that pixel, that 1 pixel, the color of color 2. Okay, if we have been through this main function over 100 times, right? So, or at least we're past the 100th pixel in the x direction, then this is going to fail, and we will assign that pixel color 1. Then we come down here, and we're going to assign the frag color we're going to output the color, right, of that 1 pixel equal to the vector 4, which is nothing more than, right, the color, the RGB color. So we've assigned that through this iteration of the pixel. So that pixel's color, the red, green, and blue color, and the alpha are going to be assigned to the frag color and thrown back to the Shadertoy node to output on the screen. So let's save that. Let's make sure that it works in Natron. So we'll go to the Natron. We will load up the new tutorial 5 DLSL. We'll click reset and then auto parameters, and indeed it works just like it does in Shadertoy. We have a width of 100 pixels that's one color, and the rest of the screen is a second color. But I don't have any GUI things up here, right? I don't have any way to change these values without going into this text and changing these values right here, right? So let's go ahead and add those uniform variables into our code so that we get a couple of GUI interfaces up here that we can change the two colors with. So let's go ahead and change that in our code. So we know, let's, I guess, slide this over and bring up the documentation again, because you may or may not remember the syntax that we need to create the uniform variables, but they are, it's right here, as you see here. So we need to create, it looks like 2 uniforms, a color 1 and a color 2. So we need to put these in a global scale, so it has to be outside the main function. Uniform and a vector 3. And we're going to call it color 1 because it's already defined in the program. And we have to set it to something, so we're going to create a new vector 3. And remember, there's a shortcut way of doing this, but let's put 0.0, comma 0.0, comma 0.0. Actually, I'm just going to continue to do it the long form way because it's just easier to understand. So we're going to put that in there, and we need the semicolon. And then what do we want this to be called in the GUI itself, then the Natron Shadertoy node GUI? We want it to be called, might as well call it color 1. But just so that we know it's defined different, let's just put color 01. Okay, so some tip information: if you hover over it, set color 1. Okay, you don't really need to put this in here. You could just leave it out, but put it in there just so we know what's going on. Okay, so we need another one. Let's go ahead and copy this. And we'll paste it in down below it. And the second one's going to be for color 2. And color 2. And this will set color 2. Okay, so we created 2 uniform variables, color 1 and color 2. We no longer want to define them in the code because we've already defined them up there as uniforms. And we basically made them both black. So we'll save this. We'll go into Natron and we will reload that code. We'll click reset parameters and auto parameters, and it's black just like I thought it would be, right? And look at, we've got the 2 GUIs up here, color 1 and color 2, and if I hover over it, yep, I get that set color 1, set color 2. So now we've got a couple of different GUIs that we can control what color 1 is going to be, the width of color 1, and color 2. Pretty cool. But what else can we do? Well, another thing we can do to this code, right, is we know that there's something creating the width of the strip. So it looks like it's a float. width of strip equals 100. Maybe I wanted to make that the width of that strip longer than or wider than 100. Could I do that with the GUI? Sure could. You're just going to do basically the same syntax as you see up here. Rather than creating a vector 3, what is this? This is a float type, right? So uniform float. And what's it called down here? Width of strip. Uppercase and lowercase case syntax is important because it won't work if you goof up. So width of strip, and we need to assign it some value, right? So we're just going to say that it equals at this point 0.0. We're going to make it so that it doesn't have any width, and we need semicolon. And what is this GUI going to be named when we see it in the Shadertoy node? We're just going to call it the width, so that we see two different things here. This is the variable name that's going to be used in the code. This is the name of the GUI widget in the Shadertoy node, remember? Okay, so the width. And we can just say set the width. And a colon. Okay, save that. And we're defining the width strip up here, so we don't want to define it down here any longer. So just comment it out so it's not being used in the code. And click save. We'll reload it and reset in auto parameters and check that out. It resets to all the default values we had in the code. We don't get to keep the colors we had when we reset the parameters, right? So let's set color 1 to green. We shouldn't see anything, right? Because the width of the color 1 is 0 at this point. And then we set color 2 to, let's call it red. And that we should see all red, right? But now what if I want to change the width to 200? I put that in there. You see it instantly changes the width of that color. So that's pretty cool. Even something this simple is useful, right? So let's put this back to 0. And you're starting to see how the Shadertoy can be used to create some cool things. What if you wanted like a fuel gauge for some type of some GUI interface you're using in your project? Well, now it's 0. And if you wanted it to be all the way up, totally full, then I actually got to go back to frame 1 and then set a keyframe. Let's remove all the, I don't know how that animation went on there. I must have done that. Remove from all dimensions so nothing's blue. And let's set the keyframe for the width at frame 1. And at frame 50, maybe we want it to be like the game 300, just so you see it move from 0 to 50. And if I do that and go back to the first frame, you should see it move up. See, it moves from 0 pixels up to 300 pixels, and in that frame limit. So you're starting to see some usefulness in all of this, I guess. At least I hope you are. Again, you can change the color of things over time. If you wanted it to be go from yellow to green as it got to the end, then you can go to that. Go to the beginning, set a keyframe for color 1 on all dimensions, and go to the next keyframe, and you want it to go from yellow to green as it fills up the tank, so to speak. Let's change this to green, and when I go back and play it, it should go from yellow to green as it moves over, and it does. See, so you're starting to see that you can create kind of your own things here, which is hopefully kind of cool. That's the fun part about programming, right? is it's only limited by your imagination. So that's pretty cool stuff. All right, moving along. Let's take a look at the next example in the tutorial. And that's 6. Let's see what it does first. Okay, looks like it's splitting the screen. So let's go ahead and read that. See what it's doing here. Let's copy that. Let's create a new one here. Let's paste it in. Let's save this as tutorial 6. Let's give it a language. So we got some color here. Save it again. All right. So resolution, the frame size. If you resize your border or go to full screen mode and come back, you'll see that the ratio and the width of the first color to the second color changes with the screen. It's because we set the width of the strip in absolute numbers of pixels rather than a proportion of the screen width and height. Okay, so we can't guarantee what the screen width is going to be. So if we hard code that as, I guess, 200 or 300, we don't know if that's half the screen, a quarter of the screen, a tenth of the screen. So it would be better, I guess, if we worked on a proportion rather than an absolute value. So that's what they're talking about here. So say you want to paint the left and right halves with different colors without knowing what the number of pixels are that you have to work with. You can learn the screen size, the width and height, in terms of the number of pixels. It's given to us in a variable called iResolution. Remember, we talked about we get some variables for free that we can use, some input variables. Let's go back to the Shadertoy documentation, and if we look at the Shadertoy inputs, right, it looks like there is a variable in here called iResolution, and check it out. That's the viewport resolution. It's the size of your screen, your screen size, and it's given to you in a vector 3. So that's what the tutorial here is telling you. So iResolution.x is the width of the frame, and iResolution.y is how high your frame is, or your screen area. So I guess what they're doing here in the main image is they're creating a couple of colors, right? And also something called pixels, so that we can work with a specific pixel or assign a value, color value, to a specific pixel. And it looks here. So what they're doing here is they're using shorthand, it looks like, for an if statement. Sugar syntax for if conditional. Yeah, okay, so this is a shorthand form for an if statement. It says if the x-coordinate of a pixel is greater than half of the width of the screen, then use color 1, otherwise use color 2. So it looks like rather than use the if-else statement, this is an easier or shorthand way of doing it. Cool. I'd rather do it with an if-else just to make it more clear, but I guess they're just showing you that you can condense it into this statement here. Frag color, and then we're assigning the frag color equal to a vector 4. This is nothing new. We've got the red, green, and blue channel and the alpha channel that we're assigning to the color of the pixel when we send it back to frag color, right? So we're seeing that every single time we go through the main function, we're only dealing with one pixel. And when we go in, we're coloring that pixel. And when we're done, we're throwing back the color of that pixel to the Shadertoy node to put on the screen. So that's what I guess all this is doing. So let's go ahead and take a look at that. We saved it, I guess. So let's pull that into Natron. Let's open up 6. Let's is reset and auto params. Of course, we lost all our GUI interfaces, but it does exactly what we expected it to. And we know now if we wanted to, we could create uniform variables to change the different colors for the different halves of the screen. So I'm not going to go ahead and I'm not going to go do that again, but that's going to be the end of this tutorial. But your homework is make 2 uniform variables that can assign different colors to the different halves of these screens. And that'll be it for this tutorial, and I'll see you in the next one.